Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we'd like to thank you for attending Reducing Corona Downtime, Installation Best Practices. Please note that this webinar is being recorded, and you will be able to access both the recording and presentation slides once they are available online, usually within 24 hours. If you have any questions during the webinar, please use the GoToWebinar question tool. You may submit a question at any time during the webinar. We will reserve time at the end to answer as many questions as we can. More than half of corona treating downtime can be associated with mistakes made during installation. Today's webinar will provide you with insights on how to verify your current systems are installed properly and tips for installing your next corona treater. Our presenters today are two industry veterans with over 35 years of experience in the field of surface treating. Matt Rajala is Enercon's service manager and oversees Enercon's team of field engineers who provide corona treating support and service to converters and extruders around the world. Mario Lenardelli is Enercon's vice president of engineering and OEM product management. Mario works closely with OEMs to integrate Enercon surface treating solutions seamlessly into their lines. Some of the highlights that Mario and Matt will cover today include corona basics, uncrating and installation of your system, important considerations when setting up your exhaust system, best practices for electrical grounding and interconnections, how to test your system after installation, the importance of training your operators, and we'll finish with a question and answer session. With that, I'll turn it over to Matt to begin talking about corona basics.
All right, thank you, Mark, and thank all of you for joining us today to kind of go over the best installation practices for your corona treater, which I truly believe will not only benefit you if you are actively installing or starting up a corona treater, but also if you have existing treaters, just to kind of make sure it's kind of a good double check just to make sure that there's not maybe inherent issues from the installation from even if it was 10 years ago that might be impacting some of the issues you're experiencing today. So yeah, with that, the first thing we'll kind of start talking about is corona basics. So we'll basically, this is just kind of a brief overview of what the corona treater is essentially doing. So it's increasing the purpose of the corona treater is to functionalize the surface of the substrate that you're treating, your material, to allow that material to wet out and this is used in a variety of applications, whether you're printing, converting, blown film extrusion, just to prepare that surface of the film for printing, adhesion, lamination, anything like that down the line. Here's just some visual representations as far as an untreated surface. You got an ink droplet, kind of like a bead of ink, and then when you treat it, that's what we talk about wetting out. And of course, we have other presentations. If you want to learn more about this, on our website, we have several other webinars and videos that goes into further detail of what the corona treater does. And yeah, so basically, we'll also talk about how the corona is created. It is basically what we see here is the purple discharge, basically the corona discharge. That's at the electrodes. What you're seeing here at the top is the electrodes, and then the ground roller. In this case, a non-conductive ceramic covered ground roll with metallized material or whatever kind of material you have going through. In this case, a universal roll, basically, universal system. And then this slide just kind of shows some of the block components of any corona treater system. You got the power supply that's taking your main input power, from the utility. 60 or 50 hertz converts it to a high frequency, high current output going down to the high voltage transformer. And then from that transformer, that's stepping up to a high frequency, high voltage output, which that high voltage potential is across the electrodes. In this case, just for example, a segmented electrode bar is shown, but that could be ceramic electrodes or any type of electrode there where you got the potential. and then the roller is at ground potential. So basically the return path of all of that power. So, and then your film, your substrate, your material is going to be going, wrapped around that roll, going through the corona treater, and that's where we're doing our work.
All right, thanks, Matt, for getting us started on the basics. We're going to send a poll question out. Corona treaters are obviously used for so many different types of applications, and we just wanted to get a feel today of our audience in terms of what are you guys using corona treaters for. So I'm going to launch this poll question. You can select more than one answer if you're doing multiple applications, printing, coating, laminating, blown film, cast film. And we'll just give everyone a few seconds here to submit their responses, and then we'll let you know what we have in the audience today. All right, we'll go a few more seconds. Looks like we've got about 3/4 of the votes tallied up. And it's looking like printing is definitely going to be the #1 application for Corona in our audience today, followed closely by laminating, blown film, and coating. So we appreciate you guys sharing that with us, and that will help Matt and Mario address different things for those different types of installations. We will now go back to the presentation with Matt talking about uncrating and installation.
All right, thanks again, Mark. And yeah, so basically we'll talk about uncrating and installation. Kind of the very first thing, you get a new corona treater, new piece of any kind of equipment, kind of goes along the lines of inspecting all the first thing you do. You get at your dock door, inspect all the packaging. With our systems, the last couple of years we've been putting shock labels just to make sure that there's nothing obvious, just to give some kind of indication for our customers once they receive the equipment, just to see if there's any unforeseen shock or something like that in the transport. Of course, inspect all the packaging, just see if there's anything. If you do notice anything, definitely let the carrier know right away and everything. And again, just like anything. So now uncrating, once you start opening up the crates, taking a look at everything, pulling the equipment out of the packaging. One thing I wanted to just mention is locate the manuals and drawings for your system, which we package those inside. Typically, 99.9% of the time they're packaged inside the power supply cabinet. So that's one of the things that you'll want to take a look at that. And also, it's a good idea to make sure that does get into the hands of the affected people, the installers, also the maintenance managers and all that kind of stuff. And if you ever need any other additional copies emailed or anything like that, always contact Enercon. We'll be happy to email that information to you as well if you need further copies or software versions of it. And yeah, basically as you're uncrating, remove all the straps, shipping bolts, follow the instructions, note on any labels. For example, we got the ground rollers. Typically, depending on your system, may have a dielectric coating. So, be sure not to damage that coating when you're taking all the shipping packaging off, especially in the case of, silicone sleeves or something like that. Just be cautious of that. Sometimes you want to leave all that stuff on until you get it. What I've seen a lot of people do is they'll leave that on until they get everything mounted, just in case there's just debris or dust in the air from the installation, metal shavings, things like that. Yeah, and then basically, when you get to that point when you are starting the installation, make sure that it's a good idea to make sure that there's enough room to allow access for maintenance. Because remember, for any corona treater, it's just kind of the nature of the beast. You have high voltage there, so to keep it clean is going to help extend the life and help prevent any downtime and things like that. So make sure that you do put it in a place where at least it'll be reachable for maintenance and cleaning. Make sure the web path direction is correct through the station. Look at the web direction arrows. Check the installation diagram. This is just kind of showing a little example from the installation diagram. Make sure it's mounted, bolted down, that the treater station and all the peripheral equipment for that matter is bolted down and mounted in accordance to the installation diagram where we show the mounting holes and everything like that. And again, if you have questions during any of this process, feel free to contact me or any of our team members here at Enercon, and we'll be glad to help answer any questions you have.
Hey Matt, just wanted to mention we do work really close with customers, with OEMs, to make sure that the treater is mounted correctly onto the line and the web path is correct. But it's always a good idea to double check that, because not all of us are perfect. So it would be a good idea to, as Matt mentioned, to make sure that once the line is in, that you got the exhaust side on the exhaust side, you got the high voltage on the high voltage side, and the web path is going in the main direction of the machine.
All right, and then yeah, when as you do get the station installed, make sure that the treater rolls are parallel and perpendicular to your web path, basically tramming the rolls, which may require shimming the frame or something like that of the treat station. Ensure all the rolls freely rotate, just kind of make sure nothing got jarred or anything like that from the handling or shipping of the equipment. And also just double check the electrode gap is 60,000ths of an inch or 1.5 millimeter. We do factory set the electrode gap, so it really shouldn't need any adjustment, but again, just with that handling with the transit, things like that, just kind of, if anything, you might want to even just do maybe a spot check, and if you check kind of the ends, the middle, and everything seems good there, it should be good. But and just in general, make sure that nothing else might have shifted or changed. And then with the power supply installation, power supply cabinet, inspect the intended location, ensure that there'll be adequate airflow around the power supply, that it's not completely enclosed or something like that, or, if there is, and some of our standalone units will be, but yeah, again, if there's any questions, just let us know. Wall or floor mounted power supply is required, just so it's not loose. And then also, if you'd like, it's a good idea to, well, in fact, you are going to be opening the power supply anyhow, opening that cover for the interconnection, like the output wires, potentially. So when you open it up, just kind of take a quick visual inspection, make sure everything is good from the transit and handling. And yeah, so then also with narrow web installations, again, flexibility in the location. There's going to be, various OEM press designs. Usually with a narrow web, it's going to be predetermined where you're gonna put it and everything. And again, that's like Mario mentioned. The sales team will work closely with you in that process to avoid any surprises and things like that, to make sure it goes straightforward for you. And something else too, because this is important, one of the main things with treater installation is going to be the exhaust duct installation. So we have a portion of this webinar we're going to go through the importance of the exhaust duct installation, and also help arm you with information to prevent any problems or pitfalls that may arise, down the road. And so again, the purpose of the treater exhaust is to remove two byproducts that are created. The two main byproducts that are created just naturally from the corona discharge process is ozone. That's just from the electrical arcing through air, is naturally going to produce ozone, and also heat. Because of all that power being dissipated from the electrodes, there's going to be a fair amount of heat created. So here's just kind of a cross-section of our electrode assembly, showing the efficient exhaust design, where we're basically pulling ambient air, if you will, through around all of the surfaces of the electrodes, and that's going to, remove the ozone and also remove that heat that's created, and then just it pulls it through the exhaust ducting and then out of the working area. So that's just kind of showing how that all works. And then with the exhaust duct run, because this is going to be something that either your team is going to be installing or your contractor is going to be installing. A few considerations we're going to talk about is the material, the type of material used for exhaust ducting, the diameter of the ducting is important, the length, always keep the length to minimum if possible, and number of elbows, keep that to a minimum, and the blower and blower installation, everything. And again, a lot of these are will provide a lot of different tips and things to help your success. With the exhaust duct guidelines, here's just kind of an example. And on the installation diagram of your system, it's going to mention a minimum required CFM, cubic feet per minute of exhaust air flow. And again, if you got any questions about the exhaust airflow needed for your system, feel free to contact us. But this is just showing how the diameter, because one of the things on our installation diagram, or on the exhaust duct guideline card, and there's a sample shown on the right side there, you notice a note that says use a reducer, basically, or basically where you're taking the exhaust duct line that you're installing and then reducing it down into the flange on our treater station. And the reason we can't really provide a universal size on that treater station exhaust duct flange is because we won't always know how long your exhaust duct run is going to be. You see that the diameter of the exhaust duct is going to depend on two factors, really. How the total length of the exhaust duct and also the number of elbows. And so if say your exhaust duct run is only 50 feet and say it has 4 elbows, yeah, then in this case a 10-inch diameter duct would be fine. But if you have a very long, or say there's a lot of different bends, 8 elbows, and it's 175 feet, then you're going to need a 14-inch duct diameter for that 175 feet or whatever the total run is. So that's, again, one of those important matters too of why it's good to keep that duct run as short as possible.
Yeah, that's really true, Matt, because I think, I don't know how often you work with customers, but the biggest question I get is, well, what diameter duct do I use? Even though there's a 6-inch, a 4-inch duct diameter on the treater station, doesn't mean you can run a 4-inch or a 6-inch all the way up to your blower, and it all depends on where your blower is located. The big thing is, as Matt mentioned, is you got to determine the length of your duct run and number of 90-degree elbows or 45-degree elbows that are in your duct run. Because, for instance, you could use this as a guideline for every 90-degree elbow, it's almost equivalent to a 20 to 30-foot straight duct run. So the more number of elbows you have in your duct run, the better. There's an understanding that you're going to lose a lot of static pressure in that case. So you want to make sure that you want to reduce the number of 90-degree elbows in your duct run as much as possible, just so that you maintain the proper static pressure at the treater station itself. The blowers that we supply, we usually build in about 2 inches of static pressure loss due to the ductwork. And in order to keep that to a minimum, you want to make sure that you got the minimum length and minimum number of 90-degree elbows in your duct run.
And Matt, Murray, I was just going to mention that card that you see on the lower right, that's attached to the exhaust of every system that ships out of Enercon. It's very specific to your installation. If you don't have that any longer and you're curious, we can always send you a replacement of that so you can verify the exact recommendations for your system.
All right, thanks, Mark. And yeah, so something else too that's important is the exhaust blower location, where you're going to mount it. Something that is always worth mentioning, I know it sometimes sounds a little funny, but I have seen it on quite a few occasions where, don't place the exhaust blower discharge near any fresh air intakes or HVAC that might inadvertently pull that ozone, basically the treater exhaust discharge back into the working area. So always kind of keep that in mind. You usually want to, when you're discharging it out of the roof or whatever, have a tall enough pipe. And remember, ozone is heavier than air, so it is going to sink as it goes out of the facility. So kind of keep that in mind with where you're locating that discharge, just so it's not sinking back and coming back into any fresh air intakes. Also, a couple things. Whether you mount now our exhaust fans are rated for outdoor use. The fan is itself. And that's because you can mount it outside of the building. Some of the benefits to that is it maintains a negative exhaust pressure and reduces noise level inside your working area. However, on the flip side, I've talked to some customers who they prefer to mount it inside their facility, so then it's not creating noise or whatever for the neighbors and things like that. So if mounting inside, it's always nice to mount it as near as possible to where the exhaust duct exits the building. And the reason is you just have less positive pressure of that exhaust line, that if there is any leaks or whatever in the exhaust ducting, it's just less chance that it's going to be leaking back into the working area. And kind of going back to some of the other things and some new things, keep the exhaust duct runs as short as possible. A few reasons: you can maybe get by with a little smaller diameter ducting, but also just to reduce your cost of duct material. Steel joints to avoid pressure loss, minimize elbows and transitions, and then also it's important to have like a precipitation hood or something at the exhaust discharge. Actually, one other thing too, just on the point of exhaust duct materials, is to make sure always use ozone resistant materials for the exhaust ducting. That would be PVC, aluminum, stainless steel. One of the big no-nos: do not use galvanized duct because that's going to corrode because it doesn't have the best ozone resistant characteristics.
So Matt, with customers who end up not being able to follow all these guidelines, what are some of the symptoms or problems that they might see that are related to problems in the exhaust system?
Great question. So if say the exhaust is lacking, or say there is issues with the exhaust duct installation, it might run fine for you could be running along fine for years, but then they might notice premature electrode failure. They might start smelling ozone in the working area. Those would probably be the two biggest things. Would be premature equipment damage, or basically smelling ozone.
And essentially the lack of proper exhaust is therefore not properly cooling those electrodes, and that's what leads to the failure?
Exactly, yes. That is, it can be one of the main reasons for premature electrode damage. So that's why that minimum, like we talked about, the minimum exhaust airflow is very important to check and make sure from the get-go. And we'll review a little bit later as far as how we can confirm that, because we're talking about the ideal duct installation, which is first and foremost, and then we'll kind of address. And then just one other thing, if you go back one slide, the exhaust blower direction. There is directional arrows on the housing of the exhaust duct fan, and this is a very important thing for startup installation to make sure that the impeller is rotating the correct direction as shown on the directional arrows on the fan housing. The reason is I've talked to some people who, they feel it sucking air basically, but that doesn't necessarily guarantee that direction is correct in the exhaust fan, because because of the geometry of the exhaust fan. Even if the rotation's wrong, it'll still potentially pull air in the correct direction, but it will be at a significantly reduced static pressure and significantly reduced airflow. So always check the direction of the exhaust fan. And then we kind of talked about a little bit before, make sure that you have some kind of exhaust hood or some kind of angle, or whatever you need to do just to prevent any outside moisture or precipitation, rain, snow, anything like that from landing inside the exhaust ducting, which can wreak havoc. And here's just a few other tips. This is especially in environments where you might have a monsoon season, or you might have heavy rain seasons and things like that. I know around the U.S., but also I've been all over the globe where they have various environments and things. And we talked about, first and foremost, exhaust hood. Always have some angle or something at the discharge of the exhaust ducting to prevent anything from coming in. But then there's also, here's just a few other ideas that you can certainly implement proactively. Again, environment to environment. But like a trap that can collect moisture and divert it away from the treater. That's shown right there on the right-hand side, where you kind of have like a T-trap. So that's certainly something that you can implement in your exhaust duct system to help, again, help keep that moisture away from the treater as much as possible. You can run the blower continuously, and again, that's kind of more along the lines of, just always keeping air going through the treater and discharging, just so you have it going that one direction even when you're not using the treater. Or another idea too, that I know a couple of our customers have been doing is putting some kind of a damper, a safety block when the treater is not in use. So that's just basically preventing, especially if your inside your factory is at a negative pressure. What I've seen before is the outside unfiltered air, if you will, ambient air, moist air, all that stuff, gets pulled back into the facility, into the factory via the dirty treater exhaust ducting, and can cause some treater juice and moisture issues within the treater. So if you have some kind of, again, ozone resistant material is key, but some kind of damper, and that's kind of shown that like a motorized damper that can be controlled, to close when the treater is not in use. But again, just take caution that it's always open when you are running the blower. And also wet start. You can always talk to us here at Enercon. We have a wet start feature that if you do have moisture issues within your treater, we have a wet start option that will run the corona discharge at a very low power to begin with, just to kind of dry everything out, and then go to your production power after a predetermined period of time, 30 seconds or whatever you set it at.
So Matt, we talked about the exhaust and the symptoms being the smell of ozone and perhaps electrodes failing because they're not being cooled properly by the exhaust. What are some of the symptoms or problems that occur when there's moisture getting into the system?
Sure, yeah, and that is if there's moisture getting into the system, and you can kind of think of it this way: high voltage and water don't mix very well, and so you get that moisture, that water, that might come back, especially in combination with ozone and whatever is being flashed off the material, the substrate that you're treating. You kind of get like a yellowish, brownish, gunky liquid, and if that collects in the treater and you're trying to run it, then you would, to answer your question, Mark, you would get symptoms of high voltage arcing, high voltage tripping, things like that. So that is probably one of the first things, especially if it's high voltage arcing, nuisance, or you only notice it when you bring the power up or something like that. Then yeah, that can certainly be in some cases prevented with some of these features. And then just wanted to mention this ozone decomposer. This is an option that you can get from Enercon. Again, we talked about one of the byproducts of corona treating is ozone, and so an ozone decomposer can be implemented in line of your exhaust system to basically break down. There's a catalyst inside there, along with some pre-filter material to help protect the catalyst, and particulate filter to remove any debris and stuff to, again, further protect that catalyst. But this is a very good option if you need to, especially if you have local codes or requirements or something like that, for ozone emissions from your factory, this is a good option. You can talk to our sales team about the ozone decomposer, and these are just kind of some diagrams and such showing the kind of how it works. And yeah, so kind of as we were talking about, the number one way to reduce corona treater downtime is maintenance. And again, it's a lot of it, no matter what kind of corona treater it is, the same principles apply. You got high voltage, you got ground, and then you got a mixture of accumulation or dust, moisture, all that stuff. We do design our systems with ease of maintenance in mind to make it as easy as possible for your team to keep it clean.
So Matt, the one of the main points of this webinar was that installation errors end up causing about half or more of problems with corona treaters. Would most of the rest of the percent be from lack of maintenance?
Yeah, I'd say so. I mean, pretty much, and that hits the nail on the head. About half is easily preventable issues from the startup installation process. Again, no matter how old the treater is, and then the other half is just going to be maintenance. And again, we want to make it as easy for your team to maintenance and clean the treater as much as possible. And we do have a library of other information on how to clean, which we don't go too much into in this presentation, but feel free to check out our website on some of the maintenance webinars and things like that, where we kind of show how you can hinge open the electrode assemblies, clean it out, wipe it down with isopropyl alcohol and all that.
So with maintenance being very important, we're going to put another poll question out to you. And we're interested in how frequently that you perform routine maintenance on your corona treaters. So we're putting that question out. You have a choice from yearly all the way down to weekly, or even hopefully no one out there is never maintaining their corona treaters, but some people are able in certain environments to, I'll say, get away with that, Matt.
Yep.
Right, we've got about half of the votes in so far. And again, if you have questions on how to best maintain your corona treater, there's a webinar dedicated completely to that topic on our website, and you can also call Matt and his team for any advice and best practices as well. Looks like we're pretty well split. Looks like most people are looking at things at least quarterly, which is great. And again, your environment, what you're treating, can have a lot to do with how frequently you need to maintain your treater. So I'm going to close that poll currently, and we'll move on to the next topic, which is interconnection wiring and integration.
All right. Yeah, so we'll talk about the interconnection wiring and integration, and this can be, and for the purposes of this webinar, we're just talking about mainly discrete wiring and contacts, although we do offer, network communication, all that kind of stuff as well. But we'll talk mainly about the, incoming power output cable between the power supply and treat station, and again, discrete contacts. So this is an example of one of our connection diagrams. Now, in that drawing list, remember the drawing list is provided with all the other documentation, usually in the power supplies. Your key go-to drawing for startup and installation is the connection diagram. And oftentimes, too, when people call for technical support and things like that, usually our technical support team is looking first at the connection diagram just to kind of get a feel for, what kind of system it is, what kind of options you have, that type of thing. So we know what kind of integration there might be. So yeah, and this is, and the reason I mention that is because, there's going to be schematic diagrams, wiring diagrams, installation diagrams, of course. Those are going to be in your drawing list. But electrically speaking, this is going to be the main drawing that is basically made just for your system. So then we, again, it'll make installation. It shows you all your interconnection points. One of the things, input power check, always check the that your incoming power that you're going to be powering to the system is within plus minus 10% range of the rated input voltage. So yeah, that's going to be something to check out, and that's going to be at the at any power drop from your facility. So again, shown on the connection diagram. Now we're going to talk about grounding, because one of the important features, or something to keep in mind, remember we talked about before the how the high voltage, the return path is to earth ground. So earth grounding, unlike maybe some of your other equipment on the lines and presses and things like that, the corona treater is one of those things that you do want to get grounded right, for safety being one, but also just to prevent any nuisance or issues maybe down the road. So first and foremost, just power supply grounding. And then this is kind of more in line with what I was talking about before. The station frame must be grounded. We do provide, the last couple of years we've been providing I believe it's like a 6-gauge wire, 6 or 8-gauge wire, bonded to the frame of the treater station, and kind of looped up for your convenience. And that's something that you do want to ground to or attach to a good known earth ground location on the line. Inspect the ground brushes at the roll. So these are built in, or these are going to be with your system, but just kind of make sure that nothing happened from shipping or whatnot. And again, this is now the purpose of the ground brush at the roll is to protect the life of the bearings. So if you can kind of visualize, before we talked about the high voltage return path is going into the into the ground roller, and then from the ground roller, from the shaft, we have this ground brush that's basically helping that electrical current go straight to the station frame via the ground brush, instead of grounding out through the bearings, which can cause premature life of the bearings.
And Matt, this is a little more towards maintenance, but this is an area they'll want to look at when they do perform their maintenance, and could possibly be a cleaning or replacement issue.
Yes. Yep. Station interlock cable, more often than not, yeah, we have a easy connect cable from the treater station to the power supply. In some cases, for special systems or customized packages or whatnot, there might be discrete wiring that might need to be terminated. And in those cases, we're going to, lately we've been putting Phoenix lugs and wire numbers at the ends of those interconnect cables. This is just kind of showing an example of a remote mounted high voltage transformer. Oftentimes with wide web treaters, and even with our Corona Flex, we kind of have everything kind of incorporated as much as possible, the high voltage transformer married to the treat station. But in some cases where that high voltage transformer is remote mounted, this is just kind of showing the importance of, you would want 2 ground wires. Basically, that thinner ground wire is grounding the electrical enclosure box, if you will. But that other ground wire, you see it's extending out of that box, and that's going to be connected to the customer's earth ground within their facility. So shielded output cable, that's one of the things that, in fact, we freshened up this webinar because I know last time we did this startup and installation webinar, we used to just provide regular output cables, basically just 19-strand 19-strand cables that had many rules to follow. You had to, have a twisted pair. You had to have it run in aluminum conduit. There was a lot of, let's just say, it led to a lot of confusion, maybe a lot of issues that could have just been prevented by supplying a more convenient cable for our customers. So that's why we've gone now to this shielded output cable. And the reason this output cable had so many rules, if you will, is because of that special characteristic of high frequency, high current output. What would happen is if you ran that old style cable through like a galvanized conduit, which is the most popular stuff electricians use, it could induction heat and cause heating and melting and things like that. And very difficult to isolate and troubleshoot high voltage tripping. So now we have the shielded output cable, which is much easier for our customers, so they don't have to keep in mind all of those specifications. Now, the one thing that we do recommend, though, is that this is routed. You can still put it through like a cable tray or whatnot. Our only recommendation is that you have like some kind of barrier in that cable tray, separating it from other control wiring and things like that.
Matt, I got a question for you. If we go back to that connection diagram that we had up previously.
Sure.
Can you tell the customers exactly what we provide on each installation?
Yeah, so that's a good thing to note. And this is talking about a full system.
Correct.
So a full system. You kind of see the output cable. In fact, that shielded, let's start talking about the shielded output cable we just talked about, right? Actually, let me see. All right, so this shielded output cable right here, you got the power supply, and then it goes, attaches to the primary side of the high voltage transformers. So anytime you see, a cable part number wired to station by Enercon, in this case, we provide that output cable, and then, it's wired at the station by Enercon, and then the customer would just make those final attachments, just a matter of screwing down the 4 lugs into the terminals. The other thing would be, like in this case, so basically any of the things that say connected to station by Enercon, connected to motor by Enercon, connected to blower by Enercon. In this case, again, with this system, all of these cables are basically supplied by Enercon. This is the cable package. So that's something that if you want to, make sure that it's going to be as easy as possible for your installation team, talk to your salesperson about the cable package. Something that would not be provided, this would be the, fuse disconnect, the main input power basically. Typically fuse disconnect in that wiring going to the station, or I'm sorry, to the power supply will be provided by the customer. But we do have, our recommendations of the gauge of wire to use and things like that.
And our typical cable packages run anywhere from 10 meters to 20 meters in length. So that's usually predetermined before we start engineering. We usually ask, where is the power supply located in terms of the Corona treater station, so we can provide you the correct length cable for each one of your systems. The other thing, Matt, and I get some questions from customers, but I think you get that more often than I do, is when they provide a fuse disconnect, is there anything special that they need to be aware of as far as fuses, sizes, and the type of fuses?
Yeah, that is a good point, actually. A lot of times with fuses, what is it? I think Class J fuses seem to kind of have the best time delay characteristics, slow blow or whatnot, because there is going to be a heavy inrush, when in our power supply, because we got a DC bus charging circuit and things like that in the power supply. And again, depending on the model, but that's usually a good practice to have like a Class J fuse, or if you're using a breaker, like I think just make sure you have good time delay characteristics, such as like a D-curve breaker.
I think that was very interesting. And if someone hasn't purchased and installed a Corona treater in 5 years or longer, they'll probably be pleasantly surprised with how much easier it is today with what's supplied.
Yeah, definitely. In fact, I kind of joke about that after, last time we did the startup and installation webinar a few years ago. It's almost like we looked internally and said, well, wait a minute, what can we do to improve all of this stuff? And now we're happy to do a freshened up webinar for you. So yeah, this is just high voltage connections. Actually, in kind of along that point of what's improved, because the days of all the styrofoam balls and all that kind of stuff for your high voltage wireways, and we're trying to get away from that as much as possible. and instead we have this fully encapsulated, shielded output for high voltage cabling. So that's going to be in the cases of remote mounted high voltage transformers, and these were just some pictures that I got from our shop, just showing the kind of the concept. And this is going to be, again, this is different than that output cable that we were talking about before, because this is the secondary side. This is at 10,000 volts between the high voltage transformers and the electrodes. And in the cases of, where we need to remotely mount or remotely route that high voltage cabling, this is a nice, safer, it's fully shielded, fully, electrically enclosed, if you will, so it can be routed safely. And then just something else to note, even though, again, a lot of our improvements over the years, we try and prevent our customers from having to even access the high voltage plenum and stuff at all. But I just throw it out there to note, because, sometimes, there might be situations in installation. Just make sure, bottom line, that all high voltage wiring has at least 2-inch clearance of any other wiring and metal and things like that. And actually, in the spirit of this topic, I should mention that anytime, say you're installing a new piece of equipment, and if you're modifying anything, definitely contact Enercon first and run it by us, because I think sometimes it's a human nature thing. Sometimes, people say, hey, I'm just going to move this electrical box over this side, and not think it's going to affect anything. I have seen some things arise that could have been ironed out maybe on the, right away, just with a quick phone call, or maybe sending me some pictures of what they were trying to do. So that is something to keep in mind, when you are installing. Again, we do our best to have those communications on the front end, so you don't have to modify anything. But if you do, or have to relocate anything, just let us know. And now going into the basically functional testing, again, respect Corona. It is 10,000 volts. We do have safety interlocks and such that for your operator and personnel safety. We always do, typically recommend, anytime you are doing any adjustments or any maintenance or cleaning, always lock out, tag out your system. But of course, we do have safety interlocks for those situations where, the roll might stop turning. That's just kind of a list on the left-hand side of our safety interlocks. The roll rotation, that's to protect the roll, for, the coating from damage. Exhaust airflow, again, very important to protect your operators from smelling ozone, and also protect the equipment from overheating. Electrode position, a very key safety interlock. There's limit switches, basically, that are checking the position of the electrode assemblies to make sure that if one of those swing open or something, that it's shutting down the power supply, basically stopping that output. And also customer interlocks. You can integrate the power supply to shut down for any requirements that you have. And now the other thing too is, and again, this is kind of, now we're in the phase, so installation's complete, electrically, mechanically, and all the exhaust duct is routed. So now this is to follow up to, measure the flow and static pressure. Again, we talked about designing your exhaust duct, based on the minimum airflow requirements to prevent those static pressure losses. But now this is, and this is definitely going to apply, especially if, hey, maybe you're watching this this presentation saying, well, wait a minute, our exhaust duct is in violation. It's too small. Well, hey, let's just, take a deep breath and take some measurements, and see where it is. Maybe it's fine or whatever, but that's going to be the best way to quantify. And again, if you don't have that equipment, which on the left, it's a differential pressure gauge for static pressure. On the right, it's an anemometer to measure airflow velocity. If you don't have that equipment, you can schedule one of our field engineers to make that measurement.
So Matt, to that point, in our maintenance webinars and heat and humidity webinars, you often make the comment about problems that won't appear right away. And in this case, if an exhaust isn't exactly where it's supposed to be, the customer may not be seeing any problems, but it could be something that in the future, if they do start to see problems, that lack of exhaust could be the cause.
Absolutely. And yeah, that's a good point, because that is one of the themes in our maintenance webinar too, is, you know, everything you might have, and I see this a lot, not a lot, but sometimes I'll see this in the field where, you know, everything's kind of borderline. Maybe, you know, maybe the exhaust is a little bit low, maybe this, and then just everything compiles over time. And then you just kind of have a combination. And again, if just having a few of those variables right from the get-go might keep you away from that edge, if you will. And yeah, it's something else, a service that Enercon provides is startup assistance and training. So this can be scheduled, you know, once you have all the equipment, you know, installed and ready to go by your installation team, then you can contact Enercon and have us go. And again, during the process, if there's any questions that arise, and oftentimes too, we'll get phone calls from your electricians or contractors and things like that, and are happy to answer. Certainly happy to answer questions during the installation phase to prevent problems down the road. And then once everything's ready, you can schedule service by us if you'd like. And our field engineers are, for the most part, well, yeah, they're all, you know, they have bachelor degrees in electrical engineering, and they're, you know, trained in our factory. They work in our factory. They work with treaters every day, and experience from the road, from the field. They do a complete inspection of the equipment, do the, you know, safety and operational testing. So all of those safety interlocks, all of those, you know, any questions that you have, they'll certainly address on site. They can perform an assessment of your maintenance procedures and parts inventory, and that's a key thing too, because, you know, that's another thing where, even though maintenance and cleaning is designed with ease in mind, you know, I'll see just, you know, sometimes people, you know, that's the other thing. A lot of people do have, you know, quarterly maintenance programs, but maybe they just might not be doing it the right way, or might not be checking the most key areas or something like that. And we can also, of course, customize any program to suit your needs. You know, if you want to, you know, operator training, maintenance training, process engineers, you know, applications, mostly hands-on, but we can also do PowerPoints and things like that in your, you know, like a classroom setting.
So some of the highlights that were covered today with the exhaust, be sure to follow the guidelines provided with your system. That information is available if you have misplaced it and can't locate it. Make sure to periodically check your airflow to ensure the exhaust is performing as expected. It's not uncommon to see changes from the initial installation, particularly if you don't have a good maintenance program and there's been some debris that's getting caught up in the exhaust system. Verify all interconnection wiring, specifically for input power and grounding. You want to avoid any high arc or high voltage arcing or nuisance faults. Be sure to test your system during startup. Take the time to train your operators. Enercon can be of assistance to you in this capacity, and also establish a maintenance program so you can avoid potential problems that might crop up once you've got that installation set up perfectly. You've got Matt's and Mario's phone numbers and email address here. Feel free to reach out to them. We're now going to move over to your questions. You can continue to submit them. Looks like we've got a few. Here's a question on web path. What changes are available to reverse the direction of a web path?
Typically, the treater station is designed to treat in the main web path direction. A lot of times some customer may have to reverse that direction, but one thing you got to keep in mind is the electrode assembly swing in the main web path, meaning that if there's any kind of obstruction coming through and hits the electrode, that electrode assembly, that impact will allow the assembly to swing away so that you're not damaging the ceramic electrodes. Customers have run the web in opposite direction, but what you want to make sure is you do have some kind of splice detection available, some type of sensor that will sense the thickness of the material in case there's a splice inside the roll that you're not aware of, and you can then open the electrodes in time so that if there is a splice or some kind of obstruction going through, it doesn't damage your assembly. So you can run it. It's not highly recommended to run it in the opposite web direction, but you can do it. But there's got to be some precautionary measures done prior to doing it.
Thanks, Mario. Here's a question on what is the minimum extraction airflow?
All right, yeah, that's a good question, and that is going to depend on primarily the size of your system. It's going to be the basically the treat width and also how many electrode assemblies you have. For example, like a narrow web, 18-inch narrow web or something might require 200 CFM, but something a much wider wide web corona treater might require 800 CFM or 1,000 CFM. In fact, some of our bigger ones that have multiple electro assemblies